I want to run through a few things like how to write a test, generating tests automatically, which we offer, more complex testing scenarios like end-to-end integration flows, and then a few benefits that you get out of a platform, right? So like things like dashboarding, data, all of that. And then for the first time ever publicly, people will have a chance to see two kind of cool new features that we've come out with. One is our brand new mocking tool. And the other thing I think which is really cool is the integration of the Sauce Connect proxy tunnels into API Fortress and API testing, and so that you can use a SaaS-based API testing tool and still be able to hit your lower environments, your local APIs, things like that. We are an API testing platform, and so because we're a platform, it is hosted, everyone logs in, has an idea of kind of seeing the same information together, and so it's very collaborative. Teams can really share data, share tests, create flows that can be used by other team members and teams, and so it's really a collaborative space. And then the other big benefit of a platform, and we'll look at it a little bit later, is that data aggregation aspect of it, right? Local API tools sit on your machine. It's just the test that you're executing. There's not really much in the reporting and dashboarding of it, but because this is a platform, we can take all of the data from the test running and build out dashboards and show you in a centralized view all of the information. So the first couple things is that you can write a test in a few different ways, and which is kind of the most important part of an API testing tool. And so you can obviously write a test completely from scratch. So I can create this test here. It's a blank test. And then I can build out the test just by using our UI components. So another huge kind of benefit is you don't need to know any specific language, any specific framework. A lot of this is heavily UI driven in the sense that we have UI components that you put together to create the API test. And I'll show you an even easier way to do this. But here's all the components that we support. Components like all of the call types, gets, posts, puts, deletes, a GitHub component to connect to GitHub and pull in data files to data drive. So in my talk earlier, I mentioned data driving tests, right? So pulling in a structured CSV file, a pipe delimited file, to then to then data drive that API and loop through those data points. All of the assertions that you would do, assert exists, is, equals, contains, greater than, matches, all of that. And then we offer kind of logic components so that you can build out similar things that you would in a code. Things like an if component, a for loop, and a while loop. And those work exactly like they do in most programming languages. A variable component to create local variables within a test scope. And I'll show later the 3 different types of variables that can be created and really how powerful this set component is. Comments work very similar to code. They're comments within the test, but also they appear in the final test report. This makes it really easy if you're sharing testing reports with teammates, or if you're going back months later to view a test result to say, well, what's actually happening here? So the comments are really helpful for that. I think the last one here is the one I love talking about. It's our fake data generator, and so it's a built-in library that can generate a ton of random data. So if you have an API that needs a first name, a last name, and an email address, and you don't really care or don't have testing data, you can use this component to generate that dynamically and randomly every single time. So huge thing that can generate names, addresses, zip codes, unique IDs, credit card numbers, stuff like that. So very helpful when it comes to testing. So this is great, and this is how I would write tests if I was doing an integration flow, end-to-end flow. But we do offer a really cool thing, which is auto test generation. And this is, I think, huge because you can get a ton of tests written in a matter of seconds and minutes, which is fantastic. And so the first thing worth mentioning is you can import 2 types of specification files, one being OpenAPI 3 spec file, and the other one being Postman collections. And so you can import those, and we actually have a nice tree structure where you can organize all of your API calls. You can put them in folders. Makes it really easy for you to come into here and find the APIs that you need to be calling. And so what you can actually do is import a spec file, call an API from here, and generate a test. And so, or actually what the other way of doing it is actually just calling an API itself, right? So if I go into here and start making an API request, And I need to pass in a header value. And so I have this basic, very simple API call here. If I make the request, and that's not correct. Oh, I missed a couple things. If I make this request here, you can see the JSON response that comes back. So cool, I called my API, I got my response. This is basically a manual API test, right? This is what a lot of people are doing in their API testing, their early stages of API testing. We make it really easy for you to go from here to automated functional testing by giving you a button. And all you do is click Generate Test. I'll give it a name. And once I hit save, what the tool's going to do is it's automatically going to create a functional schema type validation test for you. So all I did was make an API request, got the response, click Generate Test, and here we are. And so the tool will look at the request, look at the response, and create the test for you based on what it sees. And so what the tool is going to do is right at the top, it's going to put the protocol, domain, endpoint, all of that, and it's going to parameterize it. And so if we go into input set, we can see the values here, but it automatically variabilizes it. Again, really because we truly believe that you should be able to take one test and run it in all of your environments. And so having this environment section here where you can create runtime overrides for staging to say, well, in my staging environment, my domain's different, my header value is different, and a couple query parameters are different. And by just clicking this staging, it will automatically, when I run this, override to my staging variables. And so it makes it really easy for you to run this single test across all environments. And then what the tool is going to do is it's going to start validating the request and response. So it's going to say, well, in the response, I noticed the content type header of application JSON, so I'm going to validate that. I also noticed that there was a payload that returned as an array. So I'll validate that it returns an array and not just a single object. And because it's an array, I'm going to loop through it, and I'm going to validate all the objects in there. And so it's not only going to validate that there are objects there, but it's going to validate that the object should return the right type. So ID object should return integer, not string, not float, something like that. Price should return float, not an integer. Image URL returns a valid URL that's not broken, that doesn't have any weird special characters. Color object returns an array type, again, not a single object. And then loop through the color to validate the objects inside of there. And so the tool is going to go through and create this for you in seconds, in probably 1 or 2 seconds at the max. And I think that's incredible. And so from here, let's go ahead and run it, right? Take a look at the results. So if I run this test, and you'll see it's already done running. Again, why I think API testing is crucial, because it's so quick. I mean, you can see it says 1 second here, and that's really just because we don't break it down to milliseconds, but it really did not. I don't think it took a full second. And so you get a test report. Again, the benefit of being a platform is we do offer sort of reporting and dashboards, and so this report here is going to get generated every single time a test executes, whether it was manually, whether it was automated, whatever it was. And it's going to show you metadata, like where it ran, when it ran, what type of execution it was, how long, all of that. And then it's going to actually show you the full test. So the GET request, the status codes, the latency times, the download times, all of the assertions being validated, content type, integer, ID is integer, image URL is URL, color returns an array, and it's going to loop through the entire API response and validate it. If there was any failures, they would be highlighted here in red, and we would be able to see details about the failure, what the assertion was looking for, what it found instead, and all of that. We have this test. It took seconds to create. What do we do from here? I think the one thing that is very unique to our platform is the fact that we have a built-in scheduler. And so when we talk about monitoring your APIs, I think this is the easiest way to do it, right? You're not going to run a build or a pipeline every 10 minutes. You want to be able to run this frequently, and you're not going to necessarily run a build that frequently. And so what we offer is a built-in scheduler. And so if I publish my API test here, what will happen is the scheduling option will appear, and I can jump over. Oh, and it warned me because I didn't save my test. So always remember to save your test. And if I pop over to the schedule, I can actually create a schedule for this. So what I can do is I can say, run this test every 5 minutes of every hour of every day of every month. If I wanted to run it less frequently, like every 10 minutes or at the half an hour mark and at the hour mark, whatever it is, I can do that. I can create the schedule. I got to save the schedule. If I named it, And once I save that, the tool will then just execute this API test on that schedule of every 30 minutes. And it will just go and it will store all the data in our dashboards, which is what we'll look at next. But we also offer notifications and other sorts of data pushing. And so we'll look at that in a second. But you have your schedule running. What do? You go into your dashboard so that you can see all of the results. And so when you jump into the dashboard, there are a couple things to look at. By default, we show you 3 days worth of data. And then you can always filter that to whatever date range you want, however long of a date range you need. You can filter by mode, so monitoring mode, on-demand mode. If you wanted to see only the failures, you could do that. But the cool thing is when you come into here, in the logs view, you're going to see all of the tests that are being executed within this project. And so it's going to say, well, I've actually executed 10 tests in the past 3 days. 1,027 were successful, and I had 283 failed tests. And so you can see I have a few failed tests here. And you can always go back, and any test, you can click on it. And you'll get the same test report. You can view it. I clicked on this one on purpose because I wanted to show you what a failure looked like. So you can see here quantity. So it's actually looking for quantity is a URL, and it found the integer 1 instead, and so it failed. The cool thing is when a failure does occur, we provide you the stack details, and so you can see the request information as well as the full response, all of the headers, and the full API response at the point of failure. And so it makes it really easy to debug. You can come into here and say, well, why did my API test fail? What happened? Here's my API response. What am I seeing here? What am I testing for? That is kind of the reason why the reporting is the way it is because we want you to be able to come in here and debug really fast, go back, fix things, and move on. The other thing that the dashboard gives you is a metrics view. The metrics view is going to show you all of the APIs that are being called within your projects, the method they're called with, the status code response, as well as the latency and fetch times of that API. You can also see things like how many requests were made, how many were successful, how many failed. And success and failure really is determined by the status code. So 200s and 300s are successful calls, 400s, 500s are failed calls. This can actually be customized within a test. So if you want to do negative testing, let's say, and say like a 4 or a 501 is an acceptable or an actually expected response, then you can actually dictate that in the test, and the test would then consider itself a success because you wanted it to be that. So negative testing is crucial as well, and we do offer that as an option. I did want to show an example of a little bit more of a complex test, like an integration end-to-end test, and how we do that in API Fortress. And so here's an example of an end-to-end test where I need to string together multiple API calls. I have my post request where I'm using username and password to authenticate myself, and then grabbing an access token from that response and passing it into my next API call where I add things to my cart and validating again using that access token, and then making another call to the GET request with the same access token, validating what the response is. And then if I had a logout delete function, I would throw it right at the bottom, and this would be a full encompassing API test. The way we make integration testing really easy is whenever you make an API request within the tool, you actually store its full response into a variable, and that variable can be used within the test whenever you need to and referenced. And so if for access token, I can simply call user payload and then do dot token to grab the token element. It's all dot notation. So if token had an element within it, I could do dot token, token dot ID, and that would grab the ID element. It's also worth mentioning that everything inside of this $ curly bracket is actually executable JavaScript code. So if I wanted to do any sort of data manipulation, I could, right? So I could say for token, I actually want to do a split on token or dash, grab 0, and this is probably not correct code syntax, but this would actually evaluate that, do the split, and then store whatever part of the split I want stored in the access token. So that's also doable, and little tips and tricks for data manipulation. Variables can be created multiple ways. You can have a string type variable, and that would then show, it would just store it as a string type. There's a data type variable that would allow you to store structured data, and so this would be if you wanted to store like a piece of JSON in keeping its structure, you could do that. Arrays, things like that would be stored in the data type. And then a language component actually allows you to put entire JavaScript code into this component. The tool has a ton of built-in libraries, so 99% of what you need to accomplish can be done just by using the tools, components, and built-in libraries. But sometimes you just need to get in there and write a script to do what you need to do, and we offer that as part of this variabilizing. Just wanted to show more of a complex test case and show how easy it is and how we believe that that should be a single test case, right? Not individual test cases that you then run as a suite, but flows that are self-contained within one test. A couple other things that I did want to point out is the fact that we do have notification abilities. And so if I set up the email notifications, whenever a test fails, I will be automatically alerted via an email that my test has failed and that I need to go look into it and figure out why. We also have something called a connector. A connector allows you to create a webhook that can then automatically send data to anywhere that can accept a inbound webhook with JSON response. So we typically see customers using this to send Slack notifications or create Jira tickets, or if you're doing data aggregation in something like Elasticsearch, send all of the data to Elasticsearch. You don't have to use our dashboards. Use whatever you're comfortable with, or use whatever you're already using for your other testing needs. So that's an option as well. And then the other side of automation, the API testing tool is also built on APIs itself. So we expose a number of APIs that generally allow you to do most things. So the API allows you to update test cases, execute test cases, pull testing data. All of that can be done via APIs. And so when you're automating through like a CI pipeline, we have APIs or a command line tool that you can just execute, call the test, run it in sync mode, have all the results pass back in JUnit, and evaluate the results right in your CI pipeline. So no plugins necessary, integrates to pretty much any CI tool out there that can make an API request or run a command line tool. So make it really easy to integrate with any tool that you may need to run with. The other part of what I wanted to show is twofold. One being our cool new mocking tool that we've created, and the other thing being the Sauce Connect tunnels and using the SAS tool to hit local APIs. And so I'm going to do this a little bit out of order because I'm going to start with the mocks so that I can create some local mocks, and then I'll show you how I can actually just use the SAS tool to call that mock, which is just hosted on my laptop, and so very relevant for developers who are having APIs locally on their machine and need to be able to still test them. And how they would do that from a SaaS application. So the first thing worth talking about when we talk about our mocking tool is that it is fully automatable via spec files. And so I think it's awesome because a lot of mocking tools out there require you to create the mocks or type out the mocks. And what we've ended up doing here is allowing you to import your OpenAPI 3 specs, and then the tool takes care of everything else. So like I can show you here, I have a sample OpenAPI 3 spec file, has multiple paths, release notes, got the parameters, response types, user endpoint. And I do want to show, you can have your examples, so schema examples that you can reference, external values, so that can be used as part of the mock as well. But I want to show something really cool is we've actually created something called xSauceCond, and it is something that's not typically in Swagger files or OpenAPI 3 spec files. But we built it in a way where if you were to take the spec, put it into Swagger Hub or any other Swagger validation tool, it would consider this a valid spec file. Basically, everything else ignores everything that's inside of this xSauceCond, except our tool will take that and use that as an extra piece of information, which is awesome. So you can create dynamic mock responses and kind of change out the schema a little bit using these conditions. It's really cool, I think, the way we've gone about doing it. So just wanted to show the spec file that I'm going to be using to generate my mocks. And so I'm going to move that out of the way. And what I'm going to do here is probably stop this mock so I can restart it. But what I'm going to do is just pass in, I'm going to call our mocking system. It's a Docker container-based tool. And I'm going to give it a port, so I'm running it on port 5000, and I'm going to pass in that spec file, the myspec.yaml that we saw earlier. And if I start running this, what the tool is going to do is it's going to create mocked endpoints that are hosted on my machine based on that spec file that I showed you earlier. And so here we go, we're up and running. So if I actually make a request here, and let me zoom in maybe a little bit to, let's say, the release notes endpoint, right? So that release notes endpoint, again, just localhost, I hit submit there, you can see the response that came back. So this is cool. It's just getting release notes, it's getting that. This contact here is actually dynamically generated. So the mock is actually dynamically generating an email every time I make a request to it. So it's really cool how we've incorporated kind of a structured spec file with some extra conditions to allow you to do dynamic context. There's a few other endpoints here. There's actually an echo endpoint, which is pretty cool. What it'll do is it'll actually, when I make the request, you can see it actually echoes my response, and it's going to return information like request headers, request body, IP addresses, all this stuff. Very useful information. Just some cool endpoints that we have built out. This tool is still growing and has a ton of other features. One of them being the fact that you can do API contract testing. So right now, as it is, it does client-side contract testing. It'll validate the contract on the client side. Once we get this up and running in a SaaS environment, you'll be able to do client and server-side contract testing. So pure API contract testing, validated, results stored in our cloud. And I think it's going to be huge to have functional API testing and contract API testing together in one tool, which is not something we've seen done anywhere else. The tool also offers logging functionality. So if I turn on the logger mode, it will actually capture API call information, pass it back to the tool, and there's actually a little logger section here. It would then capture the API request and response, and from there you are able to then store it in the request, generate a test from it, all of that. So it's very useful way to do that. So it's really good to capture these calls that you may or may not know how the request and response should look like, but it can capture it from the back end and store it that way. There is local logging functionality, so you can have logs stored locally in a log file. That's also very useful. Something really cool that I think is called, it's capturing. So what it does is I create a bunch of mocks, and I have the real APIs because it's based off a spec file. And so if I have my real APIs and I also have my mocked APIs, right? The mocked API is going to purely depend on the schema of the spec file to create the responses. But what I can actually do is turn on capture mode, call the real API. The capture will then capture this in a text file, the actual response of the API, and then it will change my mock to then reference that captured response and not use the schema. So really cool thing to do where you can have your real API data passed back into the mock. The mocking tool really has a ton of functionality that I think is very useful. What I'm going to now do is actually use the tool to test out my local mock. If I come into here now, I have my HTTP client. So what I'm going to do is grab my local API. So just throw in my IP with the port, and then I'm going to select my tunnel. And so this tunnel is basically a secure connection between Sauce Labs environment and my local laptop. And so if I hit send here, you actually see that it's calling my mock here, which is incredible. And if I actually turn off the tunnel and try again, it's just going to get stuck. It's going to try and then it'll time out because it can't reach my local network if I don't have the tunnel on. So, and a huge thing when I talk to folks, especially on the API side, it's like, yeah, we would love to move to a SaaS-based application, but our APIs are all behind firewalls and we're not allowed to open them out. We don't expose them externally. And it's like, no, we fully understand that because of the nature of APIs is a huge security flaw to have them exposed if they don't need to be, things like that. But what Sauce Labs offers is this highly secure tunneling that is used by big banks and financial systems and healthcares. And we've passed pretty much every security team that we've come across. And so this incredible security tunneling tool is now available on the API side of things, which I think is awesome. I'm a big believer in SaaS applications. I think if you don't have to maintain the application and use the application locally, why bother? And you can just see how useful it is to have it hosted and everyone can just log in. You don't have to do anything. But when it comes to APIs, it's always like I don't know what I want to do. So the tunnel, I think, offers a huge peace of mind there where you can connect locally without worrying about exposing anything.